Hello and welcome. It's your Captain Bashir Fadl as we continue our journey into the world of software development. There are some basic concepts that go across a lot of those programming languages. And today we're going to talk about one of the most important one, which is OOP, Object-Oriented Programming. Whether I'm studying Java, C Sharp, C++, Python, Epix, they all are forms of object-oriented programming languages. So their concepts are pretty much the same. If I understand that, I can demystify a lot of the concepts within programming. So let's start with the core definitions. The first thing is what's called a class. A class is basically a template. It's a blueprint. So for example, a class, which is a car, a blueprint needs a make, a model. There's certain things that makes that class: the make of the car, the model of the car, the year of the car, the color of the car. So a class is that blueprint, is that template that any car has the same definition that comes out of that. And based on that, we can have a copy of that. Now we can build it. So I can have my car. So once I go into that template and print and create my car becomes an object. That's my object. And then your copy of that is yours. So Michael's car is another object. Michelle's car is another object. Jenny's car is another object. So the class gives us the blueprint, the definition, which is called car, which is the make, the model, and the year of the car, the price of the car. But then Bashir's car is a Toyota Camry. That's the make, that's the model. The year is 2024. The price is 56,000, so on and so forth. Jenny's car is a Lamborghini 2023. The color is black, and so on. So basically, a class is that most basic concept, that blueprint. And then an object is what we create out of that. It's that instance or copy of it. So now we come to the term attributes. The information that is saved is referred to as attributes. So the class blueprint defines the attributes. So the color of a car, the make of a car, the model of the car are all attributes of that class. Now there's another important term, which is the word methods. Behaviors are represented through methods. So methods carry out operations such as returning information about an object or updating its data. So in the case of our vehicle, in the case of our car, the methods can be repaint the car, or turn off the engine, or turn on the wipers. So those are examples of methods and how we're interacting with that object. So to kind of review it and summarize it, class is equal to car. Car has attributes such as the color, the make, the model. My copy of that, my car, is my object. And we create another object called Michael's car and another object called Michelle's car. And then the way we interact with it, such as repaint the car, that's a method. Or turn off the engine of the car, that's a method. Or turn off the wipers, that's a method. So what is so special about object-oriented programming anyways? 4 key things. Number 1, encapsulation. Number 2, abstraction. Number 3, inheritance. Number 4, polymorphism. Encapsulation, abstraction, inheritance, polymorphism. Let's start by the definition of an abstraction. So abstraction basically means if you look at a device, a laptop, a cell phone, on the outside, we could refer to it as one object, a laptop, a cell phone, but in reality, there's so much complexity behind the scenes that makes that object, that makes that device. But abstraction is the process where the system only displays the most essential parts of a user and hides the remaining complex behind it. So that's the concept of abstraction, and that's one of the benefits or amazing features of object-oriented programming. The second beautiful concept about object-oriented programming is what's called inheritance. Inheritance is the concept that allows one class to inherit properties from another. Suppose we have a class called bank account. We also have another class called checking account. Checking account could be a child that inherits certain properties and attributes from the parent account. Next is encapsulation. Encapsulation is the idea of combining code and data together within a single unit. Encapsulation not only helps us to keep code and data together, but also protects it from unauthorized outside access. So we have our class, variables, methods, everything is kind of encapsulated within the same region. Next is what we call polymorphism. Polymorphism means having many forms. In the terms of programming, polymorphism is used as a concept that enables us to perform a single task in multiple ways. Suppose I want to calculate area. I can have three different equations: the area of a circle versus an area of a triangle versus an area of a rectangle. And that's an example of polymorphism. And so, as you can see, there's great advantages of object-oriented programming, such as the power and ability of code reusability. Object-oriented languages make the process of debugging easier through the concept of objects. Object-oriented programming also allows the use of data hiding through the use of encapsulation and abstraction. Object-oriented programming provides flexibility through the help of polymorphism. Efficient use of code can be used by using parent and child classes. It is also possible to create a collection of objects or an array of objects. To summarize it, basically, object-oriented programming is all about breaking down a large problem into manageable bits. And so whether you're studying Java, C++, C#, VB.NET, Python, Epix, you're going to find it's very valuable to understand those concepts, because it's going to make it easier for us to be able to write code and read code and use it, and also see the value of it in terms of code reusability and so on. Best of luck. Hope to see you in the rest of the journey.